Good morning, everyone. My name is Msagha John Mbogholi from Maseno University in Kenya. The title of my paper is Checkpointing as a Counter to Security Issues in Cloud Computing Infrastructures. To start off, I will give a quick outline of what the presentation is going to cover. First, we shall briefly discuss the problem area and then examine the motivation question that helped us to carry out the research. Then we shall talk about the research objective, followed by the approach and methodology that was used in carrying out the research. And then we shall discuss the results, their significance, and finally conclude. To start us off, we will look at the problem area, and this was based on the availability problem in cloud computing infrastructures. The figure captures the problem in one snapshot. This was a research that was carried out by Ponimon in 2018 that examined data center outage costs across 63 organizations in the US. We can see that the most significant thing that comes out from this figure is that the costs over the 6-year period have more than doubled, especially in the maximum quadrant of the figure. We can see in 2010, the costs were at approximately 1 million USD. And by 2016, we are talking about $2.4 million in terms of outage costs. This is despite research being carried out in this domain, where researchers have been trying to come up with different availability mechanisms that can bring down the outage cost in data centers. And thus, this is what led us to our motivation question. The question was, could the building of the generic AMs, that is availability mechanisms, be contributing to this problem? What do we mean by that? It means that what we found from our study is that most organizations, or most researchers rather, are building generic availability mechanisms. That is, they are not targeted at any specific outage cause. And from our study, we identified several outage causes, but in this paper, we are only covering one of these outage causes. What we asked is, could the building of specific availability mechanisms for specific outages be our solution? That is, if we build for specific outages or outage causes, could the outage costs come down? So our objective, or the objective of this research, was to determine whether checkpointing can be used as a means of countering data losses that have been caused by security breaches in cloud computing infrastructures. It is key to mention at this point that we are concerned with data losses and not data breaches, since a security breach would mean that data could be breached or data could be lost, and any of these two could happen. However, our main concern is on data losses, which inevitably lead to data center outages. So how did we go about the research? What was our approach? Our approach was to use CloudSIM, or rather an extension of CloudSIM called FT CloudSIM. FT CloudSIM is short for fault-tolerant CloudSIM. This is an extension of CloudSIM which allows us to simulate checkpointing. CloudSim by itself cannot simulate checkpointing, and so what FT CloudSim does is that it adds 6 additional modules that allow us to simulate checkpointing. We used a two-step procedure. In our first step, what we did was that we wanted to see whether our injector was working. The injector was configured using Java as the programming language, and we configured a normal distribution in terms of how often or at what point the outages should occur. The point or the purpose of using a normal distribution is to simulate an ordinary outage that could occur in a data center, since outages are not linear in nature. They can occur at any time, and this is why we used a normal distribution. So in our first step, we just wanted to confirm that our injector was working. So we simply injected the outages and then observed the results. In the second step is where we configured our availability mechanism, again in the simulator using Java, and our availability mechanism in this instance was checkpointing. We configured checkpointing in our FT CloudSim and then injected our outage causes, or rather our outages, using the injector and the normal distribution, and then observed the results. The checkpoint interval that was used was a 5-second interval. This is in line with what we found out from our literature, where it had been suggested that a checkpoint interval of 5 seconds is ideal to use, and this is what we programmed in the simulator. Here in the methodology, we see the checkpointing algorithm, which can be seen in 6 simple steps. In the first step, the broker sends the cloudlets to the data center for processing. The cloudlets are processed, or they're being processed by the VMs or virtual machines that are found in the data center. That is, the cloudlets are assigned in some order to the VMs available that have been created by the data center. So while the VMs are processing these cloudlets, the image is sent to a place, the checkpoint image generation, at intervals. In this case, 5 seconds, and then the image is stored in a database. The database that was configured in this study was Microsoft Access, which we found to be suitable. Then during the simulation, if we find that a cloudlet's data has been lost, we go to recover the latest image of that cloudlet from the database, and this image is the one that is sent back to the VM that was processing it. Now the VM can process the cloudlet from the latest image or the last image, as opposed to processing the cloudlet from the beginning, as would have been the case ordinarily. The details of how checkpointing works can be found in the paper. So I would encourage the audience to read the paper for greater details, but basically checkpoints just work like restore points in an operating system. Here we see the results from the second simulation. The first simulation basically just checked that the injector was working. So I invite the audience to look in the paper for the details. But here we shall discuss the more important outcome, which was how, or the effect of the checkpointing as far as data loss is concerned. We sent 50 cloudlets to the simulator, and we can see from the table that the time to failure varied from 4.895 seconds for cloudlet 48, that is the second from bottom, to 379.321 seconds, which was cloudlet 49 right at the bottom of the table. From this result, we found that we were able to recover 14 cloudlets out of the 15 cloudlets that had been failed in the simulation. This implies a recovery rate of 93%. Then we used two parameters to measure our availability, and these were service availability and execution availability. Service availability is the ratio of the resources allocated to the resources requested. And we find that all the virtual machines that were requested were allocated, giving us a service availability of 100%. Execution availability, on the other hand, is defined as the ratio of the tasks executed to the tasks requested. And we find that out of 50 cloudlets, only 49 were executed, giving us an execution availability of 98%. This is, of course, due to cloudlet 48, which failed before the 5-second mark, and therefore it could not be recovered because no image was generated for it. However, for the rest, we were able to recover. What do the results mean? What we see here, based on the percentages that we have just discussed, is that checkpointing can be used by cloud service providers proactively. That is, you can put in checkpointing or configure checkpointing even before the data losses occur. And it should increase significantly, that is availability, meaning we have more efficient services to users. And by extension, it also means that it is actually possible to achieve the 5 nines of availability using checkpointing. To conclude, our research has shown that checkpointing is effective for data losses at CSP level. We also conclude that there is a need to determine the effective or a more effective checkpointing interval, since we have seen the 5-second interval was not ideal because we still lost one cloudlet since it failed before the 5-second mark. Therefore, there is a need to determine more efficient checkpointing intervals, which should be done in conjunction with the availabilities of the database, meaning that we should find a way in which we could use or remove tasks quickly from the database dynamically, which have been completed, so that current tasks can be processed or saved in the database with shorter checkpoint intervals. There is also the need to protect the database itself in the event of a breach, because we are talking of security issues. Thus, data loss means we have to find ways to protect the database itself. And lastly, further studies need to be done on the availability outage relationship formula that has been discussed in the paper, which relates availability to outage causes. Thank you for listening to my presentation.